I'm Dr. Prestegaard, and I work on hydrology and geomorphology of the critical zone. And you may say, what the heck is that? And that is basically what's between the atmosphere and what we call the hard rocks, which, if you've been following petrologic literature, we also know there's biological signatures that get into rocks through subduction and other things. We see evidence of meteorologic processes that interacted with the atmosphere getting recorded in rocks. So you might think that depending upon the time scale, what the critical zone is would probably change over time as well. But we're going to ignore that for right now. What I'm looking at is how the surface and subsurface morphology, the soils, the arrangement of the topology of the topography of the watershed are influencing things like how water gets to the stream, how soils get to the stream, how solutes get to the stream, and also the organization of us, how we live in the watershed and where we live relative to the stream channels and how that affects the transport of water solutes and sediment down the systems. So we're seeing the places in the watershed where there isn't much of a riparian zone are transporting materials to the stream in a different way. In places where there is a riparian zone, we're seeing the effect of where septic systems are in the watershed is having an impact. And then I'm also having another batch of work that involves hydrologic processes in places that should be storing a lot of carbon, but may not in the future because of changes in climate and hydrology. And the two places I'm most interested in are boreal forests, which are big carbon storing reservoirs, and also wetlands. And so what I'm doing in this case is looking how climate change changes the amount of water that's coming off versus water stored, let's say, as snow, and how that's releasing some of the carbon in these places as well. So changes in carbon storage in lots of different environments as influenced by geomorphology and hydrology.